Hello, welcome to this lesson of study of Taylor series. Okay, so in this lesson, I will take you through how to find the Taylor series in more than one variable. Okay, so this time you are considering a Taylor series involving three variables. Okay, so write down the Taylor series expansion for f of x, y, z about x, y, z equals abc to the cubic term. So you're supposed to write it up to the cubic term. Now, this is how the Taylor series expansion looks like in the cubic term of three variables. So you find f of abc plus f prime of abc plus 1 over 2 factorial f prime of f prime of abc, I mean the second derivative, plus 1 over 3 factorial the third derivative of abc plus like that. Okay, so now the problem is how do I find my f prime? Why do I find my f prime and then f prime? Okay, so the first derivative formula is given by this: f prime is equal to fx plus fy plus fz all to the power 1, meaning the derivative with respect to x, with respect to y, plus with respect to z, that, and this will give us fx plus fy plus fz. Just the first derivative, that is okay. Now where you have a problem here is to expand this and this. Okay, and then come and substitute them back in our equation, then we'll be okay. Okay, so let's go ahead and do that. We know the first power, so we are okay. So f x plus fy plus fz all to the second power. Here you can use the binomial coefficient if you are okay with that, but for those of us who are not okay like that, let's use this. Okay, let's consider it like this: fx plus fy plus fz. So meaning we are dealing with only two terms, this whole term plus this term. Okay, now this will be equal to fx plus fy squared in expansion of two terms plus, what do I have, 2 fz fx plus fy plus fz squared. Okay, so when you have only one of them or all of them like this and there is no bracket on it, it means that the second derivative with respect to z, okay, this is what this squared means. So it means del something like that, del squared f del z squared. Okay, that is why I've written the z squared there as well. Okay, it means fz times itself. Okay, so it means we have fz squared. Okay, now this here, the expansion here will give me fs times itself, so we'll have s squared f squared s squared like this. Okay, plus 2 f squared, okay, xy, because I'll multiply them. So fx, so I have just this one, 2fx times fy, and in derivative is the same as f squared xy, meaning the derivative, second derivative with respect to x and with respect to y, like the two of them like that. I hope you get what I'm trying to say. When you expand, that is how you just group them. When you are multiplying, just take the, what do you call, the subscript and combine them. Okay, plus f squared y, so it means only the y, then we have to square this y, plus 2, then if I multiply these two, I have to get x z then squared, because you have two of them. Okay, f times f then z times x, so we have xz. I have plus f squared yz. Okay, there's a 2 here, if you remember, it's 2 times all of them, then plus fz squared then squared like that. I think I'm done. Okay, I think I'm done with that. So you can, if you want, you can group the squared, the single squared somewhere, something like f x squared, okay, f squared s squared plus f squared y squared, okay, like that, plus f squared z squared. You can come plus 2f xy squared plus 2 this like that, xz plus 2 fyz squared like this. You can group them, so we have 1 2 3 4 5 6 terms. Okay, now let's move ahead and go to do the cubic one. Okay, so f prime prime prime, what we just did was f prime prime, and is equal to fx plus fy plus fz cube. Okay, and this is the same as what we just did was the square, so you take the square, multiply it to one of these, that is all. So we have fs squared squared plus 2fx or 2f squared like that. Okay, plus fy squared, this like this. Let me change it. Okay, fy squared like this squared, and plus 2fxz by the second derivative. Okay, plus 2fyz then squared plus fz squared like this. So I have 1 2 3 4 5 6, it says 6 10 times fx plus fy plus fz. Now this is the first bracket, the square bracket. Inside it was the square, so I can actually or equally do this plus fy plus fz squared times itself. Okay, fx plus fy plus fz, and this will give me the cubic set. Okay, but this we know. I hope you get it. So we just come and substitute it there, and so sorry, like that. So if we expand this, first of all, let's multiply everything to fx. Okay, we are multiplying everything in this the square bracket to fx. Okay, when you multiply, you have fs squared here. If you multiply, you get fs cube. Okay, cube plus 2f s squared y, because this times the whole of this, I have x here, so when I multiply I get s squared, but y here, then everything tends to cube because I have f squared, one of the f here. Okay, but you don't write the one there, so cube like that. Then I'll have plus f x y squared. Okay, because you have y squared here, multiplying this like that, then cube, so everything will be turning to cubic function now, plus 2 f s squared z squared, sorry, cube rather, everything, this is a cubic one, plus 2 f x y z, I hope you get it, cube. Okay, plus f is it x z squared and cube like this. So this expression is actually for only x. Okay, so let's go to the y, fy. So we are done with this part. Okay, let's go to the fy and see. We are continuing. Okay, actually I have it here, so I will just copy it for you. Plus, then I have the next one is f s squared y. Okay, so I have f s squared y then cube, because y times this. Okay, plus, like I said, if you know how to use the binomial coefficient, these wouldn't be a difficult expansion for you. This will be very, very easier. I'll show you after this, but let's go through this together. Okay, then 2f x y squared. Okay, cube, because y times here we have x already there, so we have that, plus f y cube like this. Okay, plus 2 f x y z, okay, here then cube plus 2fy squared z cube, like that. Okay, wow. Plus, then the last one is f yz squared. Okay, and cube. I hope that is correct. fyz squared. Okay, so that is for the y. Let's go ahead and do for the z. Okay, I want to do the z with the red pen. Okay, so plus, expand everything with the z. Okay, so we have f s squared z. Okay, squared z, then cube plus f2f, okay, cube, then xyz. I hope you get it. Plus, okay, it's left with this one. Okay, so is it 2? Okay, f y squared z, then cube, okay, y squared z, like that, then plus 2 fx z squared, fx z squared cube, because I was just multiplying this and this, that was that, and then plus 2f yz squared. Okay, I hope you can see that cube as well. Okay, then plus fz cube. Okay, I hope you can see down here. Now let's move this to the top so that we can all see it clearly. So we have simplifications to do here. All right, after everything, the cubic derivative will be equal to, now I'm summing everything together for you. Okay, so you pick s cube, whatever cube, so let's sum the single ones here. Okay, fs cube, then the here is cube. Okay, here is cube plus fy cube, here is cube plus fz cube, here is also cube, and plus 6fxyz cube. Now let's look at the fxyz. Okay, we have 2 fxyz here plus another 2, where is it, this one, 2fx, so I have 4 of them now. Now I have another 2 here, which is 6, so I have 6 of them. Okay, look through very carefully. fxyz cube. So what you can be doing is, once I've taken this out, let's cancel that. We've taken all the 2xyz whatever, so we've taken this out as well. We've taken also this out, so you cancel them like that, so that we don't make mistake. And then we've taken these ones out, and this one. Okay, so what have you left here? We have plus 3 f s squared y cube. Now let's look for the fs squared y's. Okay, we have fs squared, we have 2 of them here, and then let's look for the green one and see s squared y. We have 1 of them here. Okay, and that will be 3, so we have to take this out as well, so that we know that, oh, we are okay. So plus, then we continue with this 3 fxy squared. Look for fxy squared and see. You have 1 here, is gone. fxy squared, you have another 2 here, so that is 3, they are gone. Plus 3 f s squared z. Okay, there should be some cube here. Okay, now let's look for s squared z. You have 2 of them here, and you have 1 here, so 3, they are gone right now. And plus, I have 1 2 3 of these, so I have 1 2 3 3 fx z squared, then cube. fz squared. Let's see, fx z squared, 1 here, then we have 2 here. Okay, so it's also 3. So you can see that for the white colors, they are done. We are done with the white colors, so we left with some few of the greens and then the red. Okay, then plus 3 f y squared z, then cube. So fy squared z, let's look for fy squared z. You have 2 of them here, and you have y squared z, you have another one here. So automatically we are left with this, and they are the same. Okay, yz squared. So let's go down here and write 3 of them. We have 3 of them present here, so plus 3 f yz squared, then cube. Okay, so this is the expansion for our third derivative. Okay, so this is how you're going to write this. This is very tedious work. Okay, it's very tedious. So we said that our solution was f of x. Okay, let me use this. F of x y z was supposed to be equal to f of a b c. Okay, plus some f prime of a b c plus 1 over 2 factorial f prime prime of a b c. Okay, plus 1 over 3 factorial the cubic a b c. Okay, now with this one, what you can do is you just substitute that everything in place of that. Okay, just put everything like this. Okay, I'm very sorry for that. You have f of x y z being equal to, now I have my f of a b c, that one we don't touch it, plus f prime. We had what, go back and you can go and check what we have for f prime. F prime, this is what we have, and then the fx means del f del x. This is what it means. So anyhow I want to write it. So, and then fy is the same, so you put your things back, del f del x. Okay, then we just differentiate along it. Sorry, you just differentiated along the x, so we just have x minus the s coordinate, which is the a, plus the f the y minus b, plus del f del z minus c. For the first derivative, that's what we had. Now you go back to the second derivative and see, this is what we had for the second derivative, these ones. Okay, so we are coming to substitute wherever you see f squared, it means del squared f, and then over with the s squared is del s squared. Okay, that's what it means. So you could have used these del f del x here in the expansion, but we'll be getting some big trouble here. Okay, so let's stick to the fx. If you can expand with the del f del x, I don't have any problem with that. So plus, okay, let's use another color so that we get everything. 1 over 2 factorial. Okay, and then with that we had del squared f del s squared, then x minus a squared. Okay, plus, okay, let me write it this side so that, or let me go and write it plus here, plus then del squared del f, sorry, del squared f, you have 2 of them, del x del y, then x minus a y minus b. Okay, plus del squared f del y squared, okay, y minus b squared, like that. Okay, then go ahead and continue like that. So you put everything in as I'm doing here. Okay, so I have plus, then you go to where are we, to del squared f del x del z x minus a z minus c plus 2 del squared f del y del z y minus b z minus c, okay, plus del squared f del z squared z minus c, okay, all squared, okay. This is what you have, and the square brackets would have to close it here, meaning 1 over 2 factorial times all these simplification. Okay, that is for the second derivative. Then you go to the third derivative. You are doing it up to the third derivative. So you write the solution we had for the third derivative, everything here. Okay, so let's use another color for this. So plus 1 over 3 factorial. Okay, then the third derivative will come. It's very, very long. Del cube f del x cube, okay, del s cube x minus a cube plus del cube f del y cube y minus b cube plus del cube f del z cube, okay, like how we go for the simplification, z minus c cube plus, then move to 6 of them, 6 del cube f del x del y del z, so x minus a y minus b then z minus c, like that. This is how you multiply them. And plus 3 del cube f del s squared del y x minus a squared y minus b plus 3 del f, sorry, del cube f rather, okay, del x del y squared then x minus a y minus b squared. Okay, so we go ahead and push this up here. This is very tedious, like if you don't have time you can't do this. And plus another 3 del cube f del x squared del z x minus a, okay, squared z minus c. We are using whatever we saw or we solved for with after the expansion, what we had. So del x del z squared, and this is x minus a z minus c squared, then plus 3 del cube f del y squared del z y minus b all squared z minus c, okay, plus 3 del cube f del y del z squared y minus b z minus c squared, okay. Then you close the square brackets for your third derivative. So this is for your third derivative. So imagine, all right, so after everything you can multiply the whole of these through by 1 over 3 factorial, and some will be cancelling, okay. So you go ahead and you do that on your own. I've simplified it for you. Let me do this. You know that this is how everything will be. So when you multiply 1 over 3 factorial here for the third derivative here, you multiply it to the whole of this, like that. So the ones with only one constant coefficient is just 1 over 3 factorial time, but here when you reach here 6, they will cancel. Okay, so you can expand, you can choose to expand or you can choose to maintain it like this. Okay, so see how and where the equation is coming from. It's from here. Okay, this is the first part. Wow. So you can choose to copy. I want you to copy this and try to simplify it. So this is the first part. In fact, the first derivative ends here. Okay, then plus you go ahead and do the second derivative, and that one's to from this part, okay, from this part, whole part up to this part, and that is the second derivative. Okay, you add all of them. That one too, you have to multiply 1 over 2 factorial through everything. Okay, so then you go ahead and also add it to this part where this thing our third derivative start from here, 1 over 3 factorial. Then go ahead and 1 over 3 factorial, and then it ends at this place. Okay, it ends at this place. Okay, so I don't believe any teacher or any of your lecturers will ask you to solve such a question, because and then plus dot dot dot, like we ended here, so it should be plus something dot 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 like that. So if it was 4 to the power 4, then you have to expand it up to the power 4, and imagine the kind of things you'll be getting. Okay, so kindly just go through, take your time and go through them. You'll be able to understand. Now I said I would love to show you some trick in solving for the expansion. Okay, if you have this to the power some n, then this is equal to n combination 0, 0, or you can start with n, 0, 0. Since we have 3 terms, then fx to the power n, fy to the power this 0, so like that, fz to the power 0, like that, their product, plus till you exhaust it. So let me use the first one and show you something. So with a square, okay, with a square, this is how it should have been. The square, this should be 2 combination 2, 0, 0. Since we have 3 terms, now write it 3 terms. This one will raise to the power the first one, fs squared, plus times fy 0, fz 0, and something to the power 0 is what? 1. So these ones will go plus 2 combination. So you start changing them like that, 2 combination, then I can choose to put 0 here, 2, 0. The idea here is that after everything, when you sum the numbers here, it should be equal to here. Okay, then fx to the power 0, fy to the power 2, fz to the power 0. Okay, that one, so you continue, and plus 2 combination, then you interchange them till you are done with the interchanging of 2. Okay, fx to the power 0, fy to the power 0, fz to the power 2. So you go ahead and see that you have fs squared, that is squared, plus fy squared, like that, fz squared for only this part. Then you continue. We are done with 2 and the zeros, so you continue with, that is the binomial coefficient, 2 combination, then you start with 1, 1, then comma 0. When I sum these, I'll get 2. Okay, so you start with fx1, fy1, fz to the power 0, and that will give me 1, so I won't write. Then plus 2 combination, the 1, 0, 1. Okay, you interchange them like that, fx, then fz will be left here. Okay, then you come plus 2 combination, you are done with this, so 1, 1, like this, then fy fz, because the x is to the power 0, so plus 2 combination, what do I have again? I have this 1, 1 here, 1, 0 here. Okay, I think that is all. We have 3, 1, 2, 3, 4, 5. Okay, I think that is all. We have, first of all, we have 3 terms up there. Okay, and these are also 3. 1, 2, is it 2, 3? Let me see. I have this. Okay, I have 3 terms here. So this one, and this. I have 1, 2, 3 here. Okay, so 6 terms. So we have to get 6 terms here. And in evaluating let me take my time and go through, okay, so that you understand. Evaluating the 2 combination, let's say n, let's say I have n, let me do it for general combination, r p, let's say q is the same as n factorial over r factorial p factorial q factorial. Okay, so this will be for 2 comma, this one for only this side, it will be 2 factorial over 0 factorial times 1 factorial times 1 factorial, like that. I hope you get it, so that you'll be able to express. So with a cube, you start doing that, interchanging them like that. Other than that, you go by the other method. Okay, thank you, and don't forget to subscribe to my channel. See you.